Okay, so today we're going to talk about nonlinear inequalities, and we're going to look at these by graphing them. So what I mean by nonlinear inequalities, we're talking about quadratics and systems where they might be a quadratic and a. So we're going to look at system as well, a systems where one will be a quadratic and we might have a linear in there as well. So let's start off with I got y is less than x squared plus 6x plus 6x plus 8. So when we see this, we're gonna forget totally about the inequality right now, because then we know that only comes into play when we figure out solid or dashed lines and shading. We should figure out first, what do we need to graph a quadratic? So ask yourself, what do you need? Well, you need x-intercepts, y-intercept, and the vertex. So that's what we need to go for. So remember, how do we find some of these things? Well, x-intercepts. Think back to what we did earlier this semester. How can you find x-intercepts? Well, you can do it by factoring, quadratic formula, and there is actually a third one called completing the square. We didn't do it, but it is another method out there. So we need to use one of those methods, but we'll either use factoring or quadratic formula, and I'm going to use factoring just to make it easier on myself, instead I don't have to use the quadratic formula. So remember, to factor, you have to use a generic rectangle and diamond. So we're going to put x squared in the bottom left, our positive 8 in the top right, and then our 6x in the bottom of our diamond, and we multiply 8 times x squared to get our top part, which is 8x squared. So we're asking ourselves, what multiplies 8x squared and adds a 6x? Well, that's 4x and 2x. So now you're going to place those in your generic rectangle. Now ask yourself, what does this factor to? Well, we should get x plus 2 and x plus 4. So we're going to ignore, like I said, we're going to ignore the inequality. We're going to put that in here. So we're going to have y. I'm just going to put equals right now, so that way we can focus on that. Equals x plus 2 times x plus 4. Okay, I know it's not equal to, but we're just going to use that to help us out in solving like we did before. So remember, to finish finding the x-intercepts, okay, the x-ints, need to put 0 in for y. So we're going to do 0 equals x plus 2 times x plus 4. Now you got to remember, what do we do next here? Okay, well, we do next here is we needed the zero product property, which means we need to figure out when is x plus 2 going to be 0 and when is x plus 4 going to be 0. Okay, because that's being multiplied. So x plus 2 equals 0 and x plus 4 equals 0. So when we solve these, we get x equals negative 4 and x equals a negative 2. So those are going to be our x-intercepts. Okay, so we have those. Now we need to find the vertex. So to find the vertex, what we're going to do is, remember, to find the vertex, you need to average your x-intercepts to get the x value. So I'm going to take my x-intercepts and I'm going to average them, which means add them together. So negative 2 plus negative 4, and divide it by 2. So negative 4 plus negative 2 is negative 6, divided by 2 is a negative 3. So that is my x value of my vertex. Now, how would you find the y value? Well, to find the y value, you're going to put it back in the original. So we're going to do y equals negative 3 quantity squared plus 6. So every time we see an x, we're putting in a negative 3. So that's what I'm doing here. And I'm plussing 8. When you solve this here, you get 9 plus a negative 18 is a negative 9 plus 8 is a negative 1. So we're going to have negative 3 comma negative 1 as our vertex. Then the last one we need to find is our y-intercept. So to find the y-intercept, remember, put 0 in for x. So we're going to do y equals 0 squared plus 6 times 0 plus 8, which some of you guys remember, it's just the 8 at the end. So our y-intercept is going to be 0 comma 8. Now, once you've done all this, now we can go about graphing. So I'm going to move this graph here into place. Okay, I'm going to zoom in to help us out with this a little bit. So we need to graph our x-intercepts, which we have are negative 2, and we have negative 4. So I'm going to put negative 2 and negative 4 on here. We'll plot those points. Our vertex is negative 3 comma negative 1, so I'm going to plot that. My y-intercept is 0 comma 8, so I'm going to plot 0 comma 8, 5, 6, 7, 8. Okay, and now remember, that point does duplicate, so we could go ahead and plot that point as well. So now, looking back at the original here, what type of inequality do we have? Well, our inequality here is a less than. So will that make it shaded or solid? Well, in this case, will it make it dashed or will it make it solid? Okay, in this case, it's going to make it dashed since there is no equal. So I'm going to put my dashed line through here. Now, obviously, this should be a quadratic, so it's got that U shape. So we have that done. Now, the last part is, remember, in inequality, you have to shade. So remember, how do you shade? Well, to shade, you're going to test a coordinate. And I would do the same thing. Test 0, 0 if you can. So I'm going to put that in there. I'm going to have y, which is 0. And we have less than, let me scroll back and make sure I get the right one. Less than 0 squared plus 6 times 0 plus 8. So we get 0 is less than 8, which is true. So I'm going to shade where 0, 0 is. Now, this one's a little bit unique here. 0, 0 is on the outside right here. So I'm going to shade on the outside. Now, this is going to go all the way around the parabola. Not just on one side. It's going to go all the way because it's on the outside part. If it would happen to fall on the inside, then I would shade on the inside. So if 0, 0 would not have worked, I would have shaded on the inside. Okay, so this is how we can see quadratics show up with inequalities. So the solutions would be everything outside of the parabola and not on the parabola either. That would be the solutions to this inequality. So our next problem here, I have a system of inequalities, and this time one's a quadratic. So we got to follow the same process here. Let's kind of find the x-intercepts, the y-intercept for the first one here. So I'm going to go ahead and factor real quickly. I have x squared, I have 5, I have negative 4x, and I have 5x squared. So ask yourself, what multiplies the 5x squared and adds the negative 4x? Well, we should get, sorry, that should be a minus 5. I wanted a minus 5. So what multiplies to a negative 5x squared and adds to a negative 4x? Well, that is a negative 5x and a positive 1x. So I'm going to fill those in, negative 5x and a positive 1x. Now factor this, and what should you get? Well, we should get x plus 1 and an x minus 5. So we're going to do the same thing. We're going to put 0 in for y. We're going to use the zero product property here. So x minus 5 times x plus 1, and we're going to set these each equal to 0. And now you should be able to find your x-intercepts. And what are our x-intercepts going to be for this case? Now that we have them each set equal to 0, well, we should get x is 5, x is negative 1. So our x-intercepts, I'll write it up here at the top. Our x-intercepts are going to be negative 5 comma 0, a positive 5 comma 0, and a negative 1 comma 0. So we're going to have a positive 5 comma 0 and a negative 1 comma 0. Now to find the vertex, remember to find that vertex, what you're going to do is, if you think you remember, what is it? Well, we're going to average them to find the x value. Okay, so we're going to go 5 plus a negative 1 divided by 2, which is 4 divided by 2, which is 2. And then to find the y value, you're going to put that back in the very original. So we're going to have 2 squared minus 4 times 2 minus 5, which gets us, see, that's 4 minus 8 is negative 4 minus 5 is a negative 9. So our vertex is going to be 2 comma negative 9. And then remember that y-intercept, I'll write it at the top, is just that number at the very end. So in this case, it's going to be 0 comma negative 5. Since everything else goes away, you just put 0 in for x. So we're going to go ahead and graph this quadratic. So I'm going to have 5 comma 0s. Let me move this graph in here so we can zoom in. So we have 5 comma 0 for one of our x-intercepts. We have negative 1 comma 0. We had negative 2 comma negative 9. So I'm going to graph that 4, 5, 6, 7, 8, 9. Okay, and our y-intercept was 0 comma negative 5. So I plot that point, and I can actually repeat that y-intercept again as well. Okay, now this one was greater than or equal to, I believe. Let me double check. Yeah, greater than or equal to. So will this one be solid or dashed? Well, this one should be solid. So you're going to make the best solid. I'll make the best solid one I can here. All right. And there is our quadratic. Now, this one's a little bit different here. We have a linear one as well. So we also need to graph this. I'm going to do that. I'm going to graph these before I do any shading here. So we're going to go, this is like we did before. We're going to go up to positive 4, graph that point. I'm actually going to do this one in green. So I'll go to pause. I'll put a star next to it so I know it's in green. It's positive 4. Okay, now this slope is down 1, negative 1/3, so that's down 1 right 3. So I'm going to do that. I'm going to keep doing that a few times here, and I'll go the other direction as well to get some points going. Now ask yourself, solid or dashed line? Well, this one is just less than, so that means we're going to have a dashed line going through. Sorry, I'm struggling a little bit. Dashed line through here, and then we should have our arrows on there as well. So last thing we need to do is test. So we're going to test for both these. I'm going to test for the red for our quadratic first, and I would do the same thing, test 0, 0. So does it work? Well, when you test 0, 0, you get 0 is greater than or equal to 0 squared minus 4 times 0 minus 5, which is 0 is greater than or equal to negative 5. So 0 did work. So I would shade everywhere where 0 worked for our quadratic, which is going to be the inside part of it. So I'm going to shade the entire inside part of my quadratic. So I just put that in red. Now the green one, we need to do the same thing. We need to test for our linear, which is going to be 0 is less than negative 1/3 times 0 plus 4. So does 0, 0 work? Well, 0 is less than 4, which is true. So we're going to shade the same side where 0, 0 is. So I'm going to shade the entire side of my green line, which is going to be all this, and on the inside here. So the part that's unique about this is the two parts that got shaded twice, okay, those are the solutions to this system. So that in this case, it's inside the parabola, but it's underneath our line. So it's this entire purple area, but also the points on the parabola that are below the line as well. Okay. So this video just demonstrates that inequalities can go on further on than just systems of linear inequalities and just single linear inequalities as well. Okay. So if you have any questions with this, please let us know. Always have a great rest of your day.